Right, students. So we will be discussing term one topic, which is rate law. So hope this video helps you to recall what we have done in term one. So rate law, it's actually an expression. So you can see this as an expression here. And we have been given a generic reaction where A and B are the reactants and P is representing the products, where small a and small b represents the coefficients. Now, when we have to write a rate law, we need to consider the R, which is representing the rate or the speed, and the concentration of the reactants, because rate depends upon concentration of reactants, and concentration is represented as square bracket. So how will you write the rate expression, rate law expression, or rate law? Rate is equal to K, where K is your constant, rate law constant, concentration of A, reactant A, concentration of reactant B. Now they have got raised power X and Y. X and Y are not the coefficients, rather they are the orders. Order of a reaction with respect to A and B. Now orders will be either given to you in the question or you will be asked to find them from the question. So, but eventually you have to write the rate law for the given reaction using the data. Now, this is another reaction. Let's take it now. That was a generic. Now it's a clear reaction. So we have got 2H2O2, hydrogen peroxide, decomposing to water and H2O, decomposing to water and oxygen. So these are my products, and this is my reactant. And here the number 2 is the coefficient. So if I have to write the rate law for first order, when they stated first order, so how will you write first order rate law? Rate is equal to K. As I told you, it depends upon concentration of reactants, which is water here, and it is first order, so it will be raised power 1. So here comes the another thing. So reaction order, or the order of the reaction, and coefficient can or cannot be same. So there is no relationship between them. So it can or cannot be same. But when you are writing rate law, you just have a reaction order, not the coefficient. So this is again a generic reaction. So here you can see, so M and N, these are orders. Coincidentally, they are matching here. So as I said, they can or they cannot be the order, but order has always to be determined experimentally. Clear? So there will be an order with respect to A, reactant A. N is the order with respect to B. When you add both the orders, you're gonna get the overall order of the reaction. Let's see some questions. The rate law of the reaction. This is the reaction being given to us, and they have given us a rate law. The overall order is X has no number, so it's 1 plus 3 is equal to 4. Next question. They have given a generic reaction and they have given you a rate law. Read the questions well to get the information out of it. The order of the reaction with respect to X. Now for that, you have to go back to the rate law and see, is there X here? The X is missing. It means the rate doesn't depend upon X. So X was 0, so why it is being omitted. Then comes the overall order. So you can see here, just there's one reactant raised power 3. So the answer gonna be 3. Next comes units of coefficient, units of specific rate constant, which is K. You cannot learn the units of K because there are different order reactions. So best way is to learn a journal formula to find its units. So where M is the molar concentration, so this is molar, okay, which can also be written as moles per liter, minus overall order, minus 1, and time inverse. Clear? So let's see, let's try out a question. If A was first order and B was second order, so they are saying rate is equal to K. If A was first order and B was second order, so overall order is 3. So what will be the unit of k? So substitute the values. M minus overall order is 3 minus 1 time inverse. You can use second, that's fine, but you always need to see the question what they have used. So see, you are getting the same units. So suppose you have got a first order reaction. For first order reaction, the overall order is 1. So substitute in the formula m minus 1 minus 1 time inverse. So what will be the m raised power 0 time inverse? So you can omit it and it will be time inverse. So using this useful formula, you can derive the units of any of the rate constant for any order of the reaction. Then comes, let's look at this question. The reaction below shows the decomposition of nitrogen peroxide. So they have given you a reaction. The reaction is now very important to extract the right information. The reaction is first order with N2O5. So I will suggest you quickly make a note here. N2O5 is first order and the specific rate constant is this. They have given you K. Now rate law, they said they write the rate law. How are you going to write rate law? Rate is equal to K. As they have given information about N2O5 only, so N2O5 raised power 1. So you must have rate constant and the reactants with their orders. Write the unit of specific rate constant, now K. So there are two ways, as they have already given you the value of K, so it can be directly get it from there, or you can apply the formula M minus overall order. So overall order is 1. So 1 minus 1 and time they have given you as second. So you will get M0 minus 1. So you can omit it. So you're going to get the same units. So this is how you can find out the units of K. Next question is interesting. Consider the following reaction and the information given. Write the unit. So you have to write the unit of K. Now they have given you this expression. Now you don't have the value of K. So now you're going to use the formula, right? So rate, so unit of K, M minus overall order, 3 plus 1. You can see here 4 minus 1, and as we are not sure it's a second or minute, I'm taking time inverse. So M minus 3, you don't need to put minus here now, just M minus 3. Sorry, M minus 3 time inverse is the unit. Then let's see this question quickly. So for the following reaction, the rate law is given. What is the order with respect to N2? They haven't mentioned N2 here, so it means it's 0. Order with respect to H2, so you can see raised power 2. So 2, what is the overall order? 0 plus 2, so it's 2. How could you find the orders? So they are determined experimentally. So you will be provided the data in the exam or to solve the question. Just quick one, whenever you have, so you can see the rate law. The rate law shows it's a first order reaction. So for a first order reaction, you always have a straight line on the graph, which is between initial rate and the concentration of H2. As you will change the concentration of H2, the rate will change directly. Now let's see the question. This is misplaced, it should be M and N here. Now they have given you the information, the equation is given, they have given you this equation. We will be finding M and N, which are orders. They say if NO doubles, so I have doubled it, the rate quadruples. So from here we can conclude 2 raised power M, because we are looking for 4 here, so that will 2 raised power 2 will give me this number. So M is equal to 2. Second thing, if H2 doubles, the rate also doubles. So what number should be raised power here? So it should be 1. So N is 1. So it will not be, just be mindful, it will not always be 2. It can be 3, 4. Then you have to make the relationship between those numbers. So rate is equal to K, NO, substitute the values. So H2 raised power 1. So the overall order is 3. Clear? This is the rate law for this reaction. Now you can see here the NO coefficient and order is same, but hydrogen coefficient and hydrogen order is not same. So they may or may not be same or related. Next thing, now we will be using method of initial rates. It's interesting one. Now you have been given a data, and it's a very simple data. It looks clumsy, but it is not. So here you go. Let's begin. So we have to find the order with respect to A and order with respect to B. Here you go. For A, when you are finding the order for A, B should be constant. So B has to be constant. So when you see the table, you have A, you have B, and you have rate. So B should be constant. So which trials I should consider? So this is my trial. So it's cancel is same here. So I'll consider trial 1 and trial 2. All right. So you will see the trial. So you have to get the bigger trial in the numerator. So I could see this is bigger than this. So 0.2 over 0.1 equals to 4 into 10 raised per minus 3, 2 into 10 raised per minus 3. Solve it, 2. So value of M gonna be 1. So order with respect to A will be 1. Then similarly, you have to find for B. Let me change the color of my pen. So for B, we have to keep A as constant. So choose the trials carefully. So where A is constant, so A is constant in trial 2 and 3. So I'll consider these two trials. I'm just making it a bit evident so that I don't make a mistake. Here you go. So you have to consider this and this. Sorry, I circled the wrong thing. So I'll consider these two trials. So here is the values. All right. So it's 0.2 over 0.10, 16 into 10 raised by minus 3, 4 into 10 raised by minus 3. Solve it, you'll get 4. So value of N is 2. So order with respect to B is 2. Clear? So substitute the values to get the rate law. So rate law is rate is equal to K, concentration of A with order 1, B with order 2. This is my rate law. So this is an exam style question which you can practice. So let's do it together. Now they have given you this data. I'm not reading the question. You'll read it for yourself. So pause the video, read, and let's jump into the problem. So they have given you trial, concentration of CO, concentration of Cl2, and the rates. Find the order with respect to CO. Now for CO, the Cl2 need to be constant. For Cl2 constant, analyze the data. You can't use 4 because this value is missing. So here you go. Cl2 should be constant, so I can consider trial 1 and 2. Okay, who is now this and this. So which value is bigger? The first one. So 0.120 over 0.60 equals to 2 into 10 raised by minus 3 over 1 into 10 raised by minus 3. Solve it. 2, so you'll get this as 1. So order with respect to CO is 1. Next, order with respect to Cl2. Here you go. For Cl2, CO should be constant. Here you go. So you have to see where CO is constant. CO is constant here and here. As I told you, you can't choose this trial because we have rate missing. So I'll be consider 2 and 3. All right. So trial 2 and 3. So this and this. The trial, the bigger value will go in the numerator. If you are getting your answer as a decimal or as a fraction, it means there's some mistake. So recheck your calculations. 0.200 equals to 4 into 10 raised power minus 3. 1 into 10 raised power minus 3. Solve it. You'll get 2, 4. So let's 2 raised power 2. So value of n is 2. So it means the Cl2 order is 2. So now write the rate law. They are saying rate law. So rate is equal to K, concentration of CO with order 1, as you can see, which we have found 1, and Cl2 is 2. All right. Then they say it's a leading question. So you have to go step by step. Calculate the specific rate constant. It means they are asking you to find the K. How will you find the K? You can choose, and you know, K only depends upon temperature. K does not depend on, concentration. All right. So you can choose any trial 1, 2, 3, but you can't choose trial D because data is missing. So rate is equal to, so I'll choose trial 1. Let it be trial 1 for myself. So trial 1, substitute the values. So you have the formula here. So rate is 2 into 10 raised power minus 3 K. Concentration of CO 0.120 raised power 1. 0.20 raised power 2. Now you can use your calculator, shift solve. You're gonna get your answer. Units are important. Units for K is important. So how will you derive that? Use the formula. What was the formula? M minus overall order. What is the overall order here? 2 plus 1, 3 minus 1. And you can have the unit of time now, second inverse. Second inverse, so M minus 2 second inverse, and you will get your answer. Next question, calculate the value of initial rate for trial 4. Now you have to calculate this. Now what you have to do, you will be getting your, you will be having the value of K from here. All right. So I don't have my calculator, so you will have the value here. Give me a moment. Yeah. Then using the same formula, the rate law. So you will substitute. So you don't know the rate. Substitute the value of K and substitute. Oh, everything disappeared. So rate is equal to K. So you have got the value of K from this question. Then you have to substitute the value of CO, concentration of CO, and concentration of Cl2 raised power 2. Then you can find the value of R, and the units are already given. This is the units, so you will put these units here. Let's quickly solve a question. Now consider the reaction. The reaction is second order for W. They said second order for W and first order for V. So make sure you write the information there and then things becomes easier, you know. Write the rate law. Now how will you write rate law? Rate is equal to K. Don't forget to write K. W raised power 2, V raised power 1. Determine the overall order, 2 plus 1. So it comes out to be 3. This is an interesting question. Predict the change in reaction rate when the following changes are done. So here you go. When the concentration of V is halved. So here you go. This is my formula. So they are making the concentration of V as half. It's raised power 1, correct? So what will be the rate? It will also be halved. Now your question will be, why didn't I change W? I ignored W because they did not talk about W, right? So next question is, when W is tripled. W is tripled, so 3, and it's raised power 2. Ignore the V, so 3, so it will become 9 times. When V is tripled, so rate is equal to W, ignore, V is tripled, raised power 1. So this will be 3 times, or you can write it as tripled. All right. So hope this video will help you solve so many questions being given in the practice sheet. And if any doubts, you can email me, right?